Hello everybody and welcome back to my little project looking at neural networks and genetic algorithms. I've made a few significant changes to the program, so I thought I'd make a short video detailing those, just for anyone who's interested, and also if anyone's thinking of making a similar project, maybe just to act as a pointer or two for them. The first major change has been the ability to split a large population up into smaller batches or subpopulations. This allows me to run identical simulations and yet still have a much larger gene pool, and the results speak for themselves. The simulation you can see here is identical to the one I left you with at the end of the last video, except for the fact it has a much larger gene pool. So this is a graph of the fitness function of the simulation from the last video. The dark grey bars indicate the best performer in each generation, and the green the average of the generation. As you can see, there's some improvement over time, but it's not fantastic and it's a little volatile. So now if I bring up a graph for this simulation, well, as I said, it kind of speaks for itself. The next major change has been in the ability to create more complex networks. I can now create layer topologies of arbitrary complexity, and this includes recurrent networks. The simulation you see here, and don't worry, there is more variety coming later in the video, I promise you, is identical to the previous simulation, except that now we're looking at a 4 hidden layer recurrent network rather than a simple feed-forward 2 hidden layer network. And if I bring up the fitness function for the previous simulation, and now we compare it to the current simulation, you can see there's some marginal improvement, but not an awful lot. It's something I think I need to do some tinkering with to find the ideal network for this problem. Other things I could implement with respect to the network are fully interconnected layers and long short-term memory, but we'll have to see how that one goes. So here's the final change I want to show you today. I got a bit bored of just watching the fish zoom around the tank in much the same fashion time after time, and I wanted to see if I could elicit some more complex and intelligent behaviours from them, so I decided to give them some obstacles. It's been a reasonable success. The fish you see here get a fairly hefty penalty for bumping into either the obstacles or the wall of the tank, but not so much that it's never worth it when chasing food. I have had to rework the fitness function for this. Previously, eating a pellet of food would add a number to the fish's fitness function, and bumping into something they shouldn't would just take another number away. This caused some problems because by the time the penalty was big enough to affect the fish's behaviour, the best early strategy was just not to move anywhere, and the fish would get stuck in an evolutionary rut of just spinning on the spot. As any article on the subject will tell you, get your fitness function wrong and you're not going anywhere. Literally in this case. So that's all for now. Once again, for those who are interested, I'll leave you with some footage of some fish evolving over time in a similar simulation. I am aware that the footage at the end of my last video is probably far too long for most people, so I've trimmed it right down. But anyway, until next time, thanks for watching.